Evening, and this is the third instalment from Column Cymru on Maths AS level. We're looking at powers, rules, logarithms, and solving equations using logs as well. My name is Grant Mackenzie. Let's get started. So, here the first question is solve the equation 4 to the power of 3x minus 2 equals 1 over 2 root 2. There are actually two different methods in which we can use for this. The first one of which would be looking at the powers. So if I put method 1 there. So we need, if when looking at the powers, the bases need to be the same. So on the left hand side we have a base of 4, on the right hand side we have a base of 2. It just so happens that 4 can be put as a base of 2, so we're going to put 2 squared, and then it's going to be the 3x minus 2, and then on the other side we're going to put 2 to the minus 1 times 2 to the minus half. Now we've got the basis of both being 2's. What we would do is 2 times, using obviously the rules of powers, 6x minus 4. And again on the other side, 2 times minus 3 over 2. Here we can now equate indices so that we can get 6x minus 4 equals minus 3 over 2. And then it's just a case of solving the equation. Take the minus 4 over, so we have 6x equals minus 3 over 2. In this case it's going to be plus 4. Actually, instead of plus 4, I'm going to write it as a fraction, so it's going to be 8 over 2. So that we have 6x is equal to 5 over 2, x equals 5 over 12. That would be my first way of doing it. The second method would be, method 2, would be take logs of both sides, log. Now, it doesn't matter which base you use for this, however, you have to be consistent. So if you take base 10, then they both have to be the base 10. And again, if you look at the later, you have log, which is the base 10, ln, which is the natural log using e, and then there's another button on the calculator which is log, and then you can put what base you want in. So here, take logs of both sides, we would do log of 4 and then 3x minus 2 equals log 1 over 2 root 2. Going to use the power rule here. The power rule means that the power on this log comes at the front of it, which is why I put the brackets at the start. So that's going to be 3x minus 2 log 4 equals log 1 over 2 root 2, and then 3x minus 2 equals log 1 over 2 root 2 log 4, and that actually equals minus 3/4. So take the 2 over to the other side. 3x equals minus 3 over 4, and then this time it's going to be plus, because it's 4, it's going to be. So then we have 3x equals 5 over 4, and then the 3 comes underneath it, so x equals 5 over 12, which is the same as the one before. I was just showing you that there are two different methods in which we can use for this. You take your preference. Obviously, for method 1, if we had 5 to the power of 3x minus 2 equals 2, the bases, we couldn't manipulate 5 so it becomes the same base as 2, so we would have to have used the second method. You look at each question and then decide which is the easiest one. Here, here we have the temperature, theta degrees centigrade, of a cup of tea, t minutes after it was placed on the table in the room, is modeled by the equation theta equals 18 plus 65 e to the minus t over 8. Obviously t is the time in minutes. Your previous A-level or syllabus, you would have to have either have worked out that equation, worked with that equation. I put it in there just to sort of remind you that you could get something like this, and obviously that ln is the natural log and the inverse of e. So let's start. First part of the question is A, the temperature of the cup of tea when it was placed on table. So using that, we have to work out the temperature on the cup of tea when it's placed on the table. Well, if you have a look, it is placed on the table when t is equal to 0. So we would then put t equal to 0 for part A, so that we have theta equals 18 plus 65 e to the 0. Anything to the power of 0 is equal to 1. So this is 18 plus 65, which will give an answer of 83 degrees centigrade. So when it was placed on the table, it was 83 degrees centigrade. Part B, value of T to 1 decimal place when the temperature of cup of tea was 35 degrees centigrade. So this time theta equals 35 and we are asked to work out T. So 35 equals 18 plus 65 e to the minus t over 8. Rearrange this, we have 65 e to the minus t over 8. Obviously take the 18 across, so that's going to be 35 minus 18, which is 17. And then e to the minus t8 equals 17 over 65. This time we're going to take ln of both sides. So it has to be natural log, and the reason why that is the case, so then we can go ln e to the minus t over 8 equals ln 17 over 65. The ln and the e, let me just write that ln a little bit there. And then e will cancel with each other, so you have minus t over 8 equals, and then ln of 17 over 65. And then we can put t equals, and then it would be minus 8 times ln 17 over 65, which is equal to 10.7 minutes. Now, if you have, was it to 1 decimal place, so leave it as 10.7 minutes. If it had asked you to work out the exact time in minutes and seconds, then you would have to remember that 0.7 is of a minute, so that's 70% of 60 seconds. So 76 is going to be 42, so that would be 10 minutes 42 seconds. Remembering it's not that's in the tens column, so minutes are in 60 seconds, all the rest. Next, we would be looking at part C, which is explain why, according to this model, the temperature of the cup of tea would not fall to 15 degrees C. Well, if you have a look, the temperature is equal to 18 plus 65 e to the minus t over 8. So then it wouldn't fall below 18 degrees. So the temp theta equals 18 plus 65 e to the minus t over 8. This would be 0, so theta is equal to 18. Therefore, temp does not fall to less than 18 degrees C. Okay, next question. Now we've been asked to solve. Here are basically logs. Okay, so with these logs, there are rules that we have to remember. You've already sort of covered them, so I'm not telling you anything new. But it is log A plus log B equals log A times B, multiplication rule. Then you have log A minus log B equals log A divided by B, and then the power rule, which is log A to the n equals n log A. We've already sort of used the power rule in the first part of the question. With this type of question here where it says solve, almost the first thing you would do is you would look at the power rule. In this case we're doing it in reverse. So for part A, we would start with the power rule, so this 2 is going to move over, so that is going to be log 10 x squared equal to 1 plus, and then, well, look, we can use the, don't actually think I want to use it here, because we could use the division rule, but what might be better, we sort of back this up a little bit and just bring everything across except for the 1, so that we have got plus log to the base 10 of 2 minus log to the base 10 of 5, and that equal to 1. So here we're going to use the actual multiplication rule, and then followed by the division rule, and then we would then use the idea that if we had the log, you can sort of move it out into in terms of an index number, which I'll show you how to do that in a second. So here we would go log the 10 of 2x squared, which multiplication rule, minus log 10 5 equals 1, log 10 2x squared over 5 is equal to 1. Now when you have a log equal to a number, the way this works is the base is to the power of equals what you had outside there, and that equals the bracketed sort of part. If I put them in different colors, so basically this here goes here, and then using purple, this part here goes to here. The base is obviously in this case 10. So if we say that 10 to the power of 1 is equal to 2x squared over 5, we can now solve this equation by having 50. So 5 times 10 is 50 divided by 2, so that we have x squared is equal to 25. X equals plus or minus the square root of 25, which is plus or minus 5. Now what I hope you can sort of remember from your logs, or know from your logs, is it won't be equal to a negative value. So therefore x equals 5. Okay, there's the answer. And then for part B, it's a solving question where it would be solve 3 equals 2e to the 0.5x. Take the 2 over to the other side, so e to the 0.5x equals 3 over 2. Take, and then it's natural log of both sides, so that we get ln e to the 0.5x equals ln 3 over 2. So 0.5x equals ln 3 over 2. So x equals 2 ln 3 over 2, which would give us a value of 0.81. Use that. Next question. Moving on. Okay, here we have express 4x minus 10 times 2x in the terms of y equals 2x. Sorry, in terms of y, where y is equal to 2 to the power of x. And then we go on to hence, solve the equations, and then it's just basically that, what we had previously, but instead now it's equal to minus 16. So again, we're using this idea. Notice that we could have the 2x, which is replaced by the y straight away. That 4x isn't in that format, so we're going to have to put it in as a base. So where we would start, we would put 2 squared to the power of x minus 10 times 2x. I prefer an occasion like this to put a dot for times. I'd interchange the 2 and the x so that we have 2x all squared minus 10 times 2x. Try not to write it too low down because it does look that's better. And then we would then put 2 to the power of x as y, so we have y squared minus 10y. And then if you have a look at, I'll get a better color because this here, and then compare it with this, it's exactly the same. So I can now say that this is y squared minus 10y, equals minus 16, or y squared minus 10y plus 16 is equal to 0. Again, like we said all the way through, it hasn't specifically said that you have to factorize it. It says hence solve it. So you could use the quadratic formula, you could complete the square, or you could factorize it to equal, to get the two sort of critical values. You do need a technique. I don't care how you do it. If you put it into the calculator and spits out the correct answer, they are more than likely to sort of take marks off you. You need to, because it's a method. I'm going to factorize. 16 would go as 8 and 2. Minus for both of them equals 0, so that we have y minus 2 is equal to 0, or y minus 8 is equal to 0. Y equals 2, or y is equal to 8. We then replace y with 2 to the x, so we have 2 to the power of x is equal to 2, or 2 to the power of x is equal to 8. Now we could take logs of both sides of these, or instead you can hopefully see that 2 to the power of 1 is 2, so this is x equals 1, and 2 to the power of 3 is equal to 8, so this is x equals 3. And then we've got our answers, and we can move on. Next question. Again, we're going to use the idea of our sort of log rules to sort of express as a single log in its simplest form for the first part, and then for the second part we're going to use again the rules of logs, but obviously d to the power of what it's equal times to what it should be in sort of a bracket there. Excuse me. So for the first one, I would always start with the power rule. So that third comes up. So we have part A, part B, log to the base b of x to the 15 in brackets to the power of a third minus log b 27x plus log b 3x, sorry, 3 over x to the power of 4. You can simplify them out if you want to. At the moment, leave it because I want to show you why. I will do the first part, which is going to be log to the base, and then obviously 1/3 of 15 is 5. Because it's a minus, this is going to be divided by 27x plus log 3 over x to the power of 4. And now because it's a plus, it's going to use the multiplication rule. So we have log x to the 5 over 27. Actually, I want 27 to be written slightly differently. 3 times 3 times 3 times x. And then because it's going to be a plus, we're going to sort of times. And then that's 3 times 3 times 3 times 3 over x to the 4. What I'm hoping you can see here is that you can cancel the 3 3's, because they'll just go with that. You can first of all cancel this x with the 5, so it will go to the 4, and then this x to the 4 with that x to the 4. So what you're actually left with after cancelling everything down, I've got the b's on these, would be log to the base b 3. And that's as simple as it would go. Part C then is given that log of the base d of 5 is equal to 1/3, find the value of d. So then you would say that d to the 3rd is equal to 5. If you look back at the previous slide, it would show you where it was sort of coming from. And then you would say that d equals 5 cubed, which is 125. So log of 125 of 5 is equal to 1/3, which makes sense, because 125 to the power of a third, so its third root is equal to 5. Okay, next question. So here we have solved the equation, and this is like the one with the first type that we did. However, with this one we cannot manipulate 22 into the base of 2. 4 we could, or to the base of 4. So we're going to have to just take logs of both sides. So again, part B would be 4, 3x plus 1 equals 22. Take logs sides. We would have log 4, 3x plus 1 equals log 22. As I said, the base is entirely up to you. The more modern calculators, you choose any base. If you've got an older version, then it's going to be log to the base 10. Use the power rule. You can even sort of write down on this step, use the power rule if it sort of helps you remind yourself. So it's going to be 3x plus 1 in brackets of log 4 equals log 22. Oh, it's a G, not Y. Move that over to the other side, so we have 3x plus 1 equals log 22 over 4. This isn't going to give you a nice number, but it's said to 2 decimal places. So when we do the next line, it'll be 3x equals log 22 over 4 is 2.2297, so that's going to be minus 1. 3x equals 1.2297, and therefore x is equal to 0.2297 divided by 3, which will give you an answer of 0.41 decimal places. For the second part, part C, put up here, we have given that log to the base d of z equals 2 log d6 minus log d9 minus 1. You basically want to write this as log to the something on the left hand side equals minus 1 in this case, or if there's a number equals the number, so that you can take it out of that log. Again, it's going to start with the power rule to get rid of anything there. So you have log d, that's how I write my z's, okay, because my z's look too much like a 2 if you see back in the previous example, is equal to, I'm going to use the power rule straight away, so that it is log of d, and then that's 6 squared minus log d9 minus 1, and then I'm going to move everything across to the other side, so that you have log dz plus log d9 minus log d6 equals minus 1. So we have the addition rule, then the division rule. So it will be log z minus log d36 equals minus 1. Log d9z over 36 equals minus 1. So now in this case it is d to the power of minus 1 is equal to 9 over 36. We can cancel down as z over 4. D to the minus 1, if you would prefer, you can write it as 1 over d equals z over 4. A bit of sort of cross multiplication. The d goes up, the z comes down, the 4 goes up, so that you get d is equal to 4 over z. Therefore, express z in terms of d. Z in terms of d. Okay, you need to read the question. Or z is equal to 4 over d. And then we'll solve the simultaneous equations. Right, so now we have two different logs. That's the comma between after the 8. We need to then get those logs into the right format, and then, like the previous sort of last week, we can then solve them simultaneously. We're going to have an x squared and a y, and an x and a y. So we can use in the sort of logs again. Use the multiplication rule, so it's going to be log 2 xy equals 8, which is xy equals 2 to the 8. So that would be your first equation. And this one we can stick out straight away. So it's going to be x squared over y equals 2 to the 7. This one here we can rearrange, and we can say that this would be, actually I don't know if I want to put it there. I don't think I do. I'm going to move that. There you go. So that we can say that y equals 2 to the power of 8 over x. So that's my substitution into the second equation. If I start back over here, we would have then x squared times 2 the inverse, because it's on the bottom, so it's going to be flipped, times x over 2 to the 8, and that is equal to 2 to the 7. So we would have x cubed equals 2 to the 7 times 2 to the 8. X cubed equals 2 to the 15. So then x equals 2 to the 15 multiply, which is 2 to the power of 5. 2 to the 5 is 2 times 2, 4, which is 16 times 2, which is 32. So x equals 2 to the power of 32. It is 17th equation, so we need to work out the y value. So we have y equals 2 to the 8 over x. So y equals 2 to the 8 over 2 to the 5. Rules of indices, then you would sort of take away, so that's going to be 2 to the power of 3, which is 8. So solving these simultaneous equations, it would be x is equal to 32 and y is equal to 8. Next question. Solve 2 to the 4x minus 1 equals 3 to the 5 minus 2x, given your answer in the form of x to the base 10. So this time they've told you which base to use. Therefore, that's the base we're going to use. How we would go about this, again, if you look at the bases, on the left hand side we've got a 2, on the right hand side we've got a 3. There's no way we can manipulate them so that they would have the same base. So we would go straight into taking logs of both sides, up to base 10 of both sides, so that we have log 2 4x minus 1 equals log 3 5 minus 2x. Power rule, straight down, so it's going to be 4x minus 1 log the base 10 of 2. And I'm going to write 10 after this because it's just an extra thing you have to write. And then it's going to be 5 minus 2x to log the base 10 of 3. This is split it, and then you basically want to isolate x equal to as it is at the top there. So 4x log 2 minus log 2 equals 5 log 3 minus 2x log 3. Just like equations, so move in the minus log 2 over, that becomes plus log 2, and move in the minus 2x log 3 over, so that becomes plus 2x log 3. If I show you in purple, this one will go over here, and this one will go over here, which would give us 4x. Would give us the 4x log 2 plus 2x log 3 equals 5 log 3 plus log 2. Notice how it wants to be written as one log on top and one leg on the bottom. Sorry, log on the bottom. Factorize this left hand side by taking out x. So then we have log 2 to the power of 4 using the power rule, plus log 3 to the power of 2, again using the power rule. I'll stick an intermediate step in there as well. This is going to be log 3 to the power of 5 times 2 using the power rule followed very quickly by the multiplication rule. Yeah, just to remind you, is when I take the x out, then it's going to be log 2 to the 4. This one would be when I take the x out, this is going to be log 3 squared. Okay, so again, this is going to be then x will equal log 3 to the power of 5 times 2 is 486. And on the bottom, when I combine these two using the multiplication rule, it is log 2 to the 4 times 3 squared. So that we get x equals log to the base 10 of 486 over 10 of 144. Again, written in the sort of format. Question number 9. So with question 9, we would again be looking at power rule to start off with. So again, how you would like this written to solve this equation. You've got that 2, which is a constant. So you want the 2 on the left, on the right hand side. You want one singular log on the left hand side. So it's a case of manipulating it to get it the way that you want it to look like. So the first thing you need to do is power rule. So these are all log to the base 8. So it's going to be log 8 2 cubed plus log 8 7 minus x, and I'm going to bring that plus log 8 over as well, so that becomes minus log 8x equals 2. So everything's on the left hand side is got a log, everything on the right hand side is a singular number. Next thing would be to multiplication rule. So we have log base 8 of 8 plus that, so it's going to be times 7 minus x minus log 8x equals 2, and then division or rule would be log 8 times 7 minus x over x, and that is equal to 2. Where we'd go from here is, so we have the base to the power of what is equal to is equal to what is in a bracket. So 8 squared is equal to 8, 7 minus x over x. You can divide straight away by the 8 on the other side, because it is sort of times here, you can bring that underneath there, so that it saves you sort of doing 8 squared is 64 and then dealing with it that way. We can also move the x up to the other side as well, so that we have 8 squared x over 8 equals 7 minus x. Stick a line down here. The 8 squared, that squared will cancel that 8, so I'm left with 8x equals 7 minus x. The minus x goes over, so it's going to be 8x plus x is equal to 7. 9x equals 7 over 16. Is equal to 7, and then x equals 7 over 9. Which then solves it, and we can sort of check if we needed to whether that was the case by putting it into the equation. I'd only sort of say we could do that if we have the time, otherwise you'll be moving on to the, which is using algebra, find in terms of logs the exact value of y for which 3 to the power of 2y plus 3 to the y plus 1 is equal to 10. So this again is going to be a quadratic. So if we go straight into it, right, let's split it up. So we know that using algebra, find we're looking to make sure that we can identify each of the different things. What I mean by that is so that we have 3 to the power of y squared plus, so that is just rules of indices that you can split the powers, and it's just basically because they're multiplied together, you can put what you want in one bracket and then obviously the other part of the power in the other part of the bracket. For 3y plus 1, if you again think of rules of indices, the plus means that they were originally times. So it's going to be 3 to the power of 1 times 3y, and that's equal to 10. So what we could do for this one is we could substitute another letter. As long as you don't use y, it doesn't make any difference. So I'm going to say that 3 to the power of y is equal to m. So now we have m squared plus 3m minus 10 equal to 0. Again, if we're using quadratics, they must equal 0, so I brought the 10 across. How you solve this, factorize it, complete the square, or formula, it doesn't make any difference, as long as you have a technique. Right, so minus 10 will be split into 5 and 2, so it's going to be plus 5 and minus 2. So m minus 2 is equal to 0, m plus 5 is equal to 0, m is equal to 2, and m is equal to minus 5. Then we need to, so what was our substitution? M is 3y, so we have 3y is equal to 2, or 3y is equal to minus 5. Take logs. So that we have log 3y equals log 2, and log 3y equals log of minus 5. Well, you cannot have a log of a negative number, so there's no solution to this side. So then we just focus in on this one. Here we would then put, using the power rule, y equals log 3, which is equal to log 2. So y equals log 2 over log 3. And that just asks for the exact value of y. There's no point putting what it's actually equal to, because it's asking for the exact value. I'll just leave it as, and if you want to then put a base on it, in this case I'll put 10, because it's the one everyone's got in the calculator. That's it, that's fine, you don't have to do any more than that. If, however, it asks you to sort of go on and sort of find it to however many decimal places, then you would do that. But it has asked for the exact value, so you keep it as log base 10 of 2 over log base 10 of 3. Okay, now y, there you go. Okay, if we move on to next question. Okay, so given that y equals log of the base 3x, find expressions in terms of y for each of the following. So we have log to the base 3x over 9. So I'm trying to get everything that they sort of give me now, I am trying to get into this format here. So I have log 3x over 9. It's similar to what I had, but it's still not the way I want it. So using either, in this case it's going to be the reverse multiplication, well it's not times by, reverse division, yeah, that's divided by, so I can then say that this can also be written log 3x minus log 3 9. So log 3x is y minus log 3 9. So what would be the answer? 3 to the power of what is equal to 9? Well, that's 3 squared. So log 3 9 is equal to 2. So we have y minus 2 is the way that would be written. That's part A1. And then part 2, we have log 3 the square root of x, which is log 3x to the half. So using the power rule, have, this is a half log to the base 3 of x, which is 1/2 y. So we've now found them in their simplest form. Hence or otherwise solve that. So I'm going to put a line down here so that I can show that part B, we want 2, instead of log to the base 3 of x over 9, we've already worked out what that looks like in terms of y. So that's going to be 2y minus 2. And then we have also minus log to the base 3 of root x. Well, again, we've already sort of worked that out. So that is a half y, and that's now equal to 2. If we then work our way through this, it's going to be simple equations. So it's 2y minus 4 minus a half y equals 2. So then it's going to be 1.5y, 2 minus a half, and that is equal to 2 plus 4, which is 6. So y equals 6 over 1.5, which is equal to 4. And then write an answer in simplest form, hence or otherwise solve. So we've worked out what y is. Now we know that y equals log 3x. So if we worked out what y is, then we can work out what x is. Because we have log 3x equals 4. So that we're saying 3 to the power of 4 is equal to x. So x is going to equal 3 to the power of 4, which is equal to 81. And then we're done. The next one, blank sort of page. So I thought I'd just cover the main sort of basics on this last sort of sheet. So we have the power rule, which seems to be used, I think it was every sort of question. So remember the power rule, where it is 3 log 8x plus 4 would mean that this is log 8x plus 4 cubed. We have the multiplication rule, slash addition, so it's going to be log to the 7x plus log to the 7 5, and this would be log to the 7 of 5x. I'm choosing different bases. Division, subtraction rule, log to 5 of x squared plus 2 minus log to the 5 of x, and that would give you log to the 5 x squared plus 2 all over x. Then sort of converted out of a log. So if you had log 3 x squared plus 4 equals 1, then converting it out of a log, let's put a different color, you would say that that is 3 to the power of 1 is equal to x squared plus 4, which wouldn't work. So let's change the base to an 8, and then it would work then. Because then the 4 would go across, so it's going to be 8 minus 4, which is 4x squared of that would be plus or minus 2. And convert in out of a log, and then finally, if we needed to solve to a power, if we had, I don't know, let's say 7 to the power of n is equal to 36, you would take logs of both sides, so that you would have log 7n equals log 36. And then using the power rule, n of log 7 equals log 36. And then n equals log 36 over log 7. And then you'd work out the answer. I hope this helps, and I'll see you next week for final installment, which would be looking at a past paper, probably 2018, and then I'll cover all the questions that are on there. Okay, thank you.